Imagine a wall of water, taller than a house, crashing onto the shore. This is the terrifying reality of a tsunami. Tsunamis are giant waves, but not the kind surfers ride. They are caused by powerful events beneath the ocean floor. Earthquakes, volcanic eruptions, or underwater landslides can displace massive amounts of water. This displacement creates a ripple effect, like tossing a pebble in a pond, but on a much grander scale. This ripple travels outward at incredible speeds, sometimes over 500 miles per hour. As the wave approaches shallower water near the coast, it slows down but grows taller. This immense wall of water can surge inland for miles, causing catastrophic damage. Understanding what triggers these monstrous waves is the first step in learning to live with their threat. Scientists have developed sophisticated tools to predict tsunamis. Seismographs, placed strategically around the world, detect earthquakes that could trigger a tsunami. Deep ocean sensors measure changes in water pressure, indicating the passage of a tsunami wave. Data from these instruments is analyzed in real time by warning centers. These centers issue alerts to coastal communities in the path of a potential tsunami. Early warning systems are crucial for saving lives, giving people time to evacuate to higher ground. However, predicting the exact size and impact of a tsunami is still challenging. Factors like the shape of the coastline and the local bathymetry, the depth and shape of the ocean floor, can influence how a tsunami wave behaves. Both China and the USA have vast coastlines bordering the Pacific Ocean, an area known as the Ring of Fire. This region is prone to frequent earthquakes and volcanic activity, making it a prime location for tsunami generation. China's eastern seaboard lies near several active fault lines, including the notorious Pacific Plate. Movement along these faults has caused devastating earthquakes and tsunamis in the past. The western coast of the USA, particularly California, Oregon, and Washington, faces similar risks. The San Andreas Fault, a major tectonic plate boundary, runs along the California coast and has the potential to unleash powerful earthquakes and tsunamis. History serves as a stark reminder of the destructive power of tsunamis. In 1976, a devastating earthquake off the coast of the Philippines triggered a tsunami that struck the southern coast of China, causing widespread damage and loss of life. The USA has also experienced its share of tsunami tragedies. In 1964, the Good Friday earthquake in Alaska generated a massive tsunami that caused devastation along the west coast, with Alaska bearing the brunt of the impact. These historical events highlight the ever-present threat of tsunamis to both countries. By studying past events, scientists can better understand the potential impacts of future tsunamis and improve preparedness strategies. Section 5, 2025, a year of specific concern. While it's impossible to predict earthquakes and tsunamis with absolute certainty, 2025 is not inherently more or less dangerous than any other year. Tsunamis are a constant threat in seismically active regions, and their occurrence is not bound by specific years. Scientists and disaster management agencies continuously monitor seismic activity and ocean conditions to provide timely warnings and mitigate risks. The focus should always be on preparedness and resilience regardless of the year. Bracing for impact. The importance of tsunami preparedness. Living in a tsunami-prone area requires constant vigilance and preparedness. Coastal communities should have evacuation plans in place, clearly marked evacuation routes, and regular drills to practice these procedures. Buildings in high-risk areas can be designed or retrofitted to withstand tsunami forces. Seawalls and other coastal defenses can help mitigate the impact of tsunami waves. But the most crucial aspect is public awareness and education. The power of prediction: how science saves lives. Advancements in science and technology have significantly improved our ability to predict and prepare for tsunamis. Early warning systems provide valuable time for evacuation, saving countless lives. Scientists continue to develop more sophisticated models and monitoring systems to enhance the accuracy and speed of tsunami predictions. International collaboration and data sharing are essential for effective tsunami warning and response efforts worldwide. Beyond the wave. The long-term impacts of tsunamis. The impact of a tsunami extends far beyond the initial wave. The destruction of infrastructure, homes, and businesses can cripple communities for years. Saltwater intrusion can contaminate freshwater sources and agricultural land. The psychological trauma experienced by survivors can have long-lasting effects. Rebuilding after a tsunami requires a massive coordinated effort involving government agencies, aid organizations, and the resilience of the affected communities. Our responsibility in a changing world, protecting our coasts for future generations. As we continue to learn more about the Earth's dynamic systems, we must also recognize our responsibility to protect ourselves from natural hazards like tsunamis. By supporting scientific research, investing in early warning systems, and promoting public awareness, we can create safer and more resilient coastal communities for generations to come. The power of nature demands our respect, and our understanding of its forces empowers us to live in harmony with our planet. By working together, we can mitigate the risks and build a safer future for all.